Okay, so this one is going to be relatively short. There's going to be three things that I wanted to show. Is one thing, so far when we worked with AdLight, remember we've been using this dataset ERA5, kind of historical weather data that you can download for the last 80 years. It has global coverage, but so far I always provided you with a file for, I think, was it Luxembourg or Portugal or something like that. And now I want to show you how you can download that yourself from a service that's called Copernicus Climate Data Store, CDS, where all of this, they provide all of this data, but you need to register for downloading that, and you can enter in queues, and you need to connect to an API. And I will tell you what an API is and how you can use AdLight to connect to it. So suppose we have the Netherlands, a shape of the Netherlands, and for that region, we want to download this rastered weather data. And we can use AdLight to connect to the Copernicus Climate Data Store. So there's not really necessary to go through a web interface and click on download, but we can do it programmatically, but only if we can authenticate ourselves. If we have an account, so you would go to this website, Copernicus Climate Data Store, and register. So that's a button where currently already says my name because I'm logged in. It's free, so you can just set up an account, and then you get an API key, which I'm not going to show completely. But basically, it's a kind of long cryptic series of characters that tells any kind of internet traffic that it is you, and it's basically associated any requests that you make for downloading data from code through code belongs to you and is associated with your account, and that you basically need to put into a file, and the instructions, they vary a little bit by operating system. You can see here already that there's one for Linux users, and there's also different setups here for Windows users and macOS users. So if you want to use that, you will have to go through that for your corresponding operating system. And it also needs a Python package called CDSAPI that is already pre-installed in your environment. So in most cases, you can ignore in the instructions you can follow online. You can ignore any kind of instructions to install something. And if you want to use this ERA5 dataset, what you also need to do, so this is the website of the ERA5 dataset. It has these tabs and download. That also has this web interface for downloading weather data. This you don't have to use. AdLight will take care of kind of building this request programmatically, but there's one thing that you need to do on the very first usage, is that at the very bottom, there's a terms of use that you need to accept. And if you don't do that, then your requests will fail. So that link is also referenced in the instructions, just something that you need to know before running this. So once you have set up this API key and registered everything and accepted the terms of use and stored the API key in the right file for your operating system, then you can use AdLight to build your cutout. So this code snippet here will look familiar to you. We've used something like that in the past, but so far this file always already existed. In the case now, where we have the API key set up and AdLight can connect to the Copernicus data store provider, we can also just reference a file that doesn't exist. And in that case, it means this is the target file where everything the AdLight downloads through the API will be stored in. So it can be just seen as a target file, and once the download of everything is successful, this file will be created by AdLight. In this case, we need to provide kind of the module where we want to download data from. AdLight can potentially download data from different data sets, not just ARA5. We need to provide a slice of the X and Y extent, so the total bounds of the region, so how far north and south and how far east and west the Netherlands extend. And it's good practice to add some small buffer around it. And we can set a time frame. For example, the 1st of March 2013. And in this case, I already downloaded that, but I could also just name it 1, 2, 3, 4. In this case, it doesn't. And this doesn't do anything yet. It doesn't connect to the API yet. If I have this case, I need to start the connection process with the cutout.prepare command. And here I'm just going to skip compression. And once that happens, that can take a moment, but I can go to the Copernicus data store and I can see here my requests. And I can click on my requests and you'll see here a few requests that are progressively kind of running. You can also see the requests I made earlier today to check that it's working. And you can see that there's progress, for example. Because I'm only downloading 1 day now. If you wanted to download a year, it can sometimes take some time. You can end up in a queue. And sometimes you maybe even want to run this overnight if the kind of the queue is very long. So this worked, and then we get a regular cutout, and we get this file here, ARA5, 1, 2, 3, 4, and C as a local file. And then we don't need to connect to the API again. Previously, we had this other cutout, and in this case, you can also just load the cutout here under cutout 2 by just providing the file name, because everything else, like the X and Y extent and the time frame, is already kind of part of the NetCDF file. In this case, you could see here, this other file would be for the full year of 2013 from module ARA5 with these bounds and these features prepared. So like solar irradiation, wind speeds, temperature, runoff, and height. So that's one thing. And will mostly be kind of one of the first steps in the group assignment. And then the other thing I wanted to flag is that potentially you're not going to use, or you're not going to choose a country that is in Europe. And that has some implications for the projections that you're going to use, because this projection 3035 that we've been using for Europe is not valid in parts outside of Europe. So there are other coordinate reference systems for the equal area and equal distance attributes, namely the 4087 projection and the Mollweide projection for the areas. Both of them are in meters, and you can use them globally for any country worldwide and has then for the corresponding attributes relatively little distortion. And you can use them like this. One is provided by EPSG service provider, one is provided by Esri. And if you have some data set of the world countries, you can convert it to an equal area projection or the distance projection. And then the distance projection that is going to be useful for calculating distances between regions or between representative points of regions based on crow fly distance or also haversine distance, which will be useful for calculating, for example, or calculating approximate lengths of transmission lines. So, for example, we have this world data set. We can call this representative point function. I think we've used that before to calculate for each of the countries a point that sits more or less in the middle and is contained inside the country here for Australia, for China, Mongolia, and so on. So now we have a geodata frame in a distance CRS. Just to show you, we have the ISO3 code and then the points in an equidistance projection. And then we can use, once we have that, and it's important that it is an equidistance projection, then we can take this points series and the function distance, it's a GeoPandas function, to calculate a distance to a common point. And if we kind of do this as a square, kind of a matrix points by points, that it's going to be symmetric, just looping over all the points and calculate the distance to all the other points. Then we can get this matrix of distances, where the diagonal is 0 because the distance of each country to itself is 0. And then we get distances, for example, between Germany and the Netherlands of 564 kilometers. And that is symmetric. So if we wanted to access that the other way, it would be exactly the same value. And that is kind of just a direct straight line between the representative points of each of the countries. Typically, you would assume something like a 25% or 50% add-on for detours that typical transmission lines would need to make. Okay, good. And the last bit that I wanted to show is that so far we've only been using HEIS as a solver. It's an open source solver, and then you don't need to set up anything about licenses, for example. You don't need to register anywhere. If you have limited patience in your group work, it can make sense to access a commercial solver for which there are free academic licenses, but that also requires you to run through a setup process that is similar to this Copernicus data store API, which is just described here. That's purely optional, but maybe worth doing if you want to iterate faster in your group work. And it all starts with another Python package, a Gurobi that is not part of your course environments, that you can add to it with either, I think in most cases it would be your conda install command. And then what you need to do is you need to register with an institutional email. And then once you're in there, you can go to request licenses. and you can request a named user academic license, kind of accept the terms, and then you will get a key displayed. Yes. Yes. You can use any version, but you will use the most recent one. But, yeah, because it's not restricted. You get the most recent one. They always come out in November, so you have a very fresh one. And then you could confirm your request. And if you I think you maybe also need to connect to the VPN or be in the university network to do that. Not entirely sure. But then you will get another API key to retrieve your license, which is why I'm not going to consider. And then it will basically show up here as one of your licenses. It's going to be a free academic license. And then you can click here to get the instructions how to bring it to your computer. But that's personal information and shouldn't be recorded. But it will look something like that. It will be a call GRB for Gurobi get key, and then you'll have another cryptic key, which you can run in the terminal with your environment activated, and that will guide you through kind of a process where you store your license file in a particular place on your computer. And then what you can do is you can load any Python network, and if you want to use Gurobi, you just specify it as a solver name. So I think in the current environment, I don't have Gurobi installed, and if your setup didn't work, then this is the error message that you're going to get, and otherwise it's going to look basically just like using Hive, but it's going to be a lot quicker.